Welcome back. So we are exploring the nodal analysis. So let's solve the second example of this series. So we have this circuit and we need to find all branch currents. So again, the rule for the nodal analysis is identify the nodes in your circuit and label them. So we can see that we have three nodes here and we label them as the first node is labeled as V1, where this current source, this resistor and this current source are connected. The second node is V2, and again at this node, this current source, this resistor, 6 kilo and 3 kilo are connected, and this is our third and the reference node, which will be labeled as 0 volt because of the ground. So let's write the equation for the first node V1. So again we will assume that all currents are leaving. So I assume that this current is leaving from this node, the current through 2 kilo ohm, and then this current, which we don't know actually. And secondly, for the V2, again we will assume that all currents are leaving. The value of this current source here is 6 milliampere. Okay, so the currents through our V2 that we believe that's through 6 kilo ohm, this 3 kilo ohm, and 6 milliampere that will basically going through this like this way. So for V1, okay, so the first thing, let's assume this current, so this is 2 milliampere, so I will put 2 milliampere plus the current through 2 kilo ohm, so that will be V1. Okay, this nodal voltage minus the second node, which is 0, so V1 minus 0 divided by 2k plus this current, okay, which is going away, okay, which is basically 6 milli, so 6 milliampere is equal to 0. So this is my first nodal equation. Similarly, we can write our second nodal equation for V2. Okay, so for V2 again all currents are leaving, so this current will be leaving, moving away, but actual direction is towards the node, so we will put negative sign, so minus 6 milliampere, then through 6 kilo ohm, so that will be V2 minus 0 divided by 6k, then through 3 kilo ohm, so plus V2 minus, so what is the second node here? The second node here is ground, so 0 divided by 3k is equal to 0. So incoming currents is equal to the outgoing currents. Now let us write, okay, simplify these two equations so that we can find the actual voltages. So nodal analysis always give us the nodal voltages. So once we know the nodal voltages, then we can find the branch currents or anything else which is desired. So we will multiply with the LCM, okay, of the denominator, which is 2k here values. So multiply the whole equation with 2k. So 2k multiply with 2 milli, so that will give me 4 plus V1 minus 0, 2k will be cancelled, so I will have V1, then again plus 6 milli times 2k, so that will be 12 milli, and kilo will be cancelled, is equal to 0. So I can basically find that the value of V1 by just simply simplifying this is basically is equal to minus 16 volt from this equation. Well, let's simplify this one. Okay, so again we can write here, so we will multiply this whole equation with we can multiply with 6k, okay, the biggest number here, so 6k multiply with minus 6, so minus 36 milli, and kilo will be cancelled, then plus V2, 6k and 6k, okay, like this will be cancelled, so we will have V2 plus again 6k divided by 3k, so we will have 2, okay, times V2 is equal to 0. So we can get that basically 3 times of V2 is equal to 36, or we have V2 is equal to 36 divided by 3, that comes out to be 12 volt. So we have value of V1, okay, that is minus 16 volt. We have value of V2, that is basically 12 volt. So once we have these nodal voltages, our question was to find all the branch currents. Okay, so basically the currents flowing through all the resistors is. So let's label them, like the current through 2 kilo ohm is I1, the current through this 6 kilo ohm is I2, just for the simplicity, and the current through this resistor 3 kilo ohm is I3. So let's find out those currents now. Okay, so to get the first current I1, so current is basically what? Difference of nodal voltages. So this voltage minus this voltage divided by the resistor value. So what is the V1? V1 comes out to be minus 16 volt. What was the V2? V2 comes out to be 12 volts. So let's find the current. Difference of nodal voltages, minus 16 minus 0 divided by 2k. So minus 16 divided by 2k, it comes out to be minus 8 milliampere. Okay, so k will be changed to milliampere. Let's calculate I2. So what will be the I2 in the same principle? I2 will be this voltage 12 minus second node divided by, so we will divide here with the 6k. Okay, so that gives me 12 divided by 6 is equal to 2 milliampere. So the last one is I3. So what will be the I3? We can write I3 simply. This voltage, what is the voltage here? 12. Okay, which is V2. So 12 minus second node, which is 0, divided by 3k. So that gives me 4 milliampere. Okay, so this way we can find all the current. So our I1 comes out to be minus 8 milliampere, I2 comes out to be 2 milliampere, and I3 comes out to be 4 milliampere. Okay, so this was the requirement of this exam. Thank you so much.